Good morning. You're probably first thing wondering is why does it say Hyper Reality Partners on the screen? So I'm going to go really fast through these first couple of slides so we can start talking about more interesting things than this. So I am Steve Duckworth. I am the Chief Technology Officer for Hyper Reality Partners. Really quick, we were founded in 2020 by a group of VR experts and enthusiasts. We were all former Void employees, and this group included co-founder Curtis Hickman. We got together and we had all of these ideas and these amazing experiences we wanted to do, and there was all these things we wanted to try in VR that we didn't have a chance to do yet. We talked a lot about, hey, what did we learn from the Void? What were the good learnings? What were the bad learnings? In the middle of this, we got a unique opportunity, and that was, hey, what if we can buy back the assets, the copyrights, the patents, the trademarks, intellectual property from the Void? And so I'm happy to say that we were able to negotiate that, and our plan is to relaunch the Void with new and more exciting experiences. So there'll be more details and press releases in the coming year about our plans there. And we're super excited because we just think that the Void, it's just the best VR experience ever. So really quick, if you're not familiar with the Void, we were a location-based entertainment VR experience. At the time of the pandemic, at the shutdown, we had 6 really amazing and award-winning experiences. It included things like Ghostbusters and Star Wars. We had an incredible Avengers and Jumanji experience as well. So we talked a little bit about, or I mentioned that the Void creates these amazing immersive VR experiences. When you go to the Void, one of the first things you're going to realize is that we really try hard to make you feel like you're present in this other world or this place that you're traveling to. We want that to feel as real as possible. We want you to really be embodied in that and immersed. There's some things that we do to promote that. And we have, with VR, we already have visuals and audio, so we have 2 of your senses already. But we do a lot of other things to really convince you and enhance your presence. So some of the other things we do, we have haptic sensations. We have both things that the person wears. We have things on the stage. We have smells that we can introduce. And we play around with temperatures, wind, mist. There's a lot of things that we can play around with. The other thing we do is that if you go to the Void and you're in the experience and you see a wall, most of the time you can reach out and people will touch it and they'll be like, there's actually a wall there, and they start feeling around. And so now in their mind they're going like, this is real, like what we're seeing is actually exist. In addition to that is if you see a chair or a bench, you can sit in that chair or the bench. And we try to get you to interact with your environment. Another important thing that we do is we engineer and design from the very beginning for all of our experiences to be a social and a shared experience. And this is really important, is after visiting the Void, I love talking to people who they go with friends or families, and they're like, hey, we went, and they, in great detail, they all start talking about what they did. And I'll be like, well, when did you go? Oh, well, we went back in 2016. And they remember these details. So I talked a little bit about some of the things we do. I found an old video clip, and in this clip, this is our Ghostbusters experience. This is actually from 2016, so this clip is 6 years old. But what I want you to pay attention to is you'll go between what is actually being shown in VR, and then you'll see outer VR, and you'll see those kind of go back and forth.
Unbelievable experience. I mean, you feel like you're a real Ghostbuster.
It was just an amazing experience to just be transported into a different world.
There's a point where you're outside and you can actually feel like a breeze against you, and you look down and you can just see the bottom of the city. It's like, oh, this is really amazing.
A lot of VR experiences don't have any sort of multiplayer, so being able to see the other people who are in the experience adds to that presence.
The actual experience of firing a proton pack and trapping a ghost. Yeah, I've been waiting my whole life to do that.
It's just amazing. I mean, you feel everything. You really feel like you're there. I'm definitely going to do this a few more times. It was awesome.
So oftentimes when we try to talk to people about what we do, is we'll say, hey, we do VR. And they'll be like, oh yeah, I've got VR at home, or I've done this cardboard thing. And so we try to explain to them, no, this is more than that. This is way more realistic. And so we had to come up with a way to really explain to people, what is it we're talking about? And so we started using the term hyper reality. And so what that is we had to define it. We had to say, what is hyper reality? So Curtis came up with a practical illusion of an impossible reality so convincing the mind accepts it as reality itself. So when we talk to people about the void now, we say, this is beyond VR. This is now hyper reality, and that it's hyper realistic for you to experience. So mentioned a little bit, we're rebooting the void. So what is the future for the void and hyper reality? We're looking at new types of experiences, longer experiences. We want we want to play around with the larger free roam areas. And we're also doing a lot of development in more immersive sensory effects. So we're going to make it even better than what you experienced before. Another important one is we're going to update the hardware and technology stack. So really quick, a quote. This is basically my job. This quote is, any sufficiently advanced technology is indistinguishable from magic. So that's kind of my job, is to make this hardware disappear. So what I did is I brought with us right here in the first chair, this is the equipment. When we first started the Void, we couldn't find anything that was available. There was nothing commercially, and so we designed, manufactured this specifically for the Void. How much does that weigh?
More than 20 pounds for sure.
It's heavy. It can get hot. It's a full, computer on the back, and it weighs several pounds. But so if we're going to make this disappear, the first thing we got to do is we got to, get rid of some of that equipment. Also, it excluded some people from being able to experience hyper reality at the Void. The technology we have today it's lighter, it has better resolution, longer battery life. So we have a lot to choose from today. And so this is what we're looking. We don't have a vest with us, but we're looking at replacing all of that with this and a haptic vest. And so if you can imagine us doing that, now more people can experience. It's more inclusive. People can do that. But this raises the question, if we get rid of that compute, where does that go? And we got to put it somewhere. And hopefully it's in a back room that's cooled and well insulated so we can't hear it. The other important thing with this is that we want to stay untethered. We want to be wireless. So this presented us with some challenges. And so as we have these discussions, it's like, what are you going to do about the bandwidth? What spectrum are we going to use? But most importantly, we have to maintain that graphic fidelity that everyone is used to that come to the Void to experience this. That's number one. So actually, we've been working with XCOM for quite a few years. We were talking yesterday about when did we first meet? When did we first start talking about this? And it's been a few years. So what I'd like to do is have Seraphin now come up and talk about how they're going to help us solve this problem for the Void. Seraphin.
Thank you. Thank you, Steve. Mm-hmm. Hi, everyone. My name is Seraphin. I'm VP of XR at XCOM. And it has been my life for the last many years to actually make XR possible in many areas of the technology. And now I'm very focused on this one. Because after working for 7 years on trying to cram everything into the HMD, I convinced myself that that's not the right solution to go forward. So very briefly, Econ Labs is a startup. We are in San Diego. It was founded by former executives of Qualcomm. So we have a long history on wireless communications and systems, end-to-end system design. We are 90 employees, most of them in San Diego, but we are very rapidly growing in India. And we actually target three columns of technology. One of them, the two first ones are the ones we're gonna talk more today, which is a wireless XR, a 60 gigahertz system that we have developed, and a compute offload, a split rendering system that we also developed from scratch. The third pillar of technology is a private 5G system, which we call it capacity multiplier, which that will be topic for another talk, perhaps next year. So let's talk about how the system very generally looks like. In one side, we have the wireless system, which actually enables the remoting of the compute. And just to make a point, remoting of the data has already happened everywhere. We don't longer keep the data on our phones, it's in the cloud. The next step is remoting of compute. And the first step is remoting to compute a service nearby, and very quickly it's gonna move to the edge and to the cloud. So our first instance is the system that I display here, which it has a 60 gigahertz wireless system, which is extremely high capacity, very low latency. And it provides seamless mobility between all the access points that you deploy within an area. The other one is our compute offload system, which allows for the application, the rendering, everything to happen on the server instead of your local device. The magic of the wireless system is the fact that it's 60 gigahertz. And that comes with some challenges and some advantages. First, advantages. We have a lot of frequency to use. And that frequency is available all around the world. So we can deploy a system in USA, we can deploy a system in Europe using frequency that has really been allocated for this WAN. The other one is that if you are working with millimeter wave, the antennas are very small. And you can actually put several antennas in one device. One example, actually the modem that we have developed, which is this big. And thanks to having multiple antennas, you can actually not only change how you focus your signal, but you can actually also steer it. You can actually send a signal to a user on this side of the room, or I can send a signal to a user on the other side of the room. And that minimizes greatly interference. So now, what will happen is I started deploying a network, and I put several of these access points around. Well, our system actually globally coordinates in such a way that when a user comes, the access point that is best suited to serve the user starts delivering data to him or her. Now, as the user moves, enjoying his XR experience, the system keeps serving them by dynamically choosing what access point to use to deliver the data to it. This has quite a bit of advantages. One of the advantages is if suddenly you have two users graphically distributed, our access point can actually transmit to both users at the same time using the same frequency. And that means that the capacity of your system increases. Now, we often talk about Wi-Fi because that's the technology that we are used more. We use it at home, we use it at this venue, and we always run into challenges. And we also, and one of the challenges is the Wi-Fi travels over walls, it travels distances, and start interfering. Different access points start interfering to each other. And in 60 gigahertz, almost every material that you see is a block of a reflector. What this means is the energy doesn't go through it. You can deploy a system on this room, and the next room can be using the same system with the same frequency, and one cannot actually listen to each other. So that realization of the system is quite massive. So if I put most walls in between, you can have two full independent systems serving two or many users, and they will not see each other. It will be completely insulated. Now, talking about insulation, this is something that people have tried with other technologies, like the lower technologies, the ones that I just talked about Wi-Fi. What do you need if you actually want to bring insulation and keep the signal into one place? Well, you need to use Faraday cages. You need to use metal-based structures so the signal doesn't leak out of where you want it. In contrast, in 60 gigahertz, everything, most materials on a traditional meeting room are blockers or reflectors. Nothing leaks out of it. So in general, summarizing, we deploy a network. We can deploy a network here. We can deploy a network in the other room, which is centrally correlated, coordinated, and it decides which access points to use to serve the users. It transmits the data, and if for any reason there was a blocking event, one user jumped over the other one and it blocked the antenna from the right side, well, the system knows that and it recovers immediately. And in that way, we can actually ensure a continuous flow of data information, a continuous uninterrupted, jitter-free experience to the user. And now let's talk about the remoted framework that we have on top of our wireless technology. It's like other split rendering systems, and where we actually completely disassociate the client from the server. So you can use different HMDs, and you can use different classes of servers. You choose the server that best fits the experience. If you want to actually go all out on the graphics, you build up a bigger server. You don't need to change your HMD. So this enables completely asynchronous of updating your HMDs and your graphics resources. And they can be completely independent. Now, we actually provide as much transparency as possible to the application developers, meaning the application developer can actually use a tethered HMD to a PC to develop, and that immediately translate to work on a split rendering system, that we provide. Another thing is that this is designed for wireless from scratch. So every single data flow is compressed and error protected. What are the high-level requirements that we can accommodate with this framework? Well, we believe we have pushed the limits of much of the hardware platforms out there. We can actually do up to 6K of resolution. We support the frame rates that are more common today, 60, 90 hertz, 120. We can actually push throughput, video throughput of around half gigabit. This ensures transparent quality. You cannot tell that it has been compressed and decompressed. That's pretty much what it is. And all the experience audio, the microphones, we provide compression and error corrections. Controllers, of course, everybody needs to support controllers. We support hand tracking, so we remote hand tracking. It's transparent for the developer. And we support both Windows 10 and Android devices. Now, what is the advantage for us to have an end-to-end system for doing XR offloading or XR remoting? Well, the advantages are that you can have those two systems talking to each other, or you can have some experiences of one system influence some of the design of the other in such a way that you implement IP packet scheduling. Very, very, very hard QoS requirements. You can actually implement overload when the system, for any reason, starts getting into trouble. The system can tell the render servers, can you slow down a little bit? Can you actually throttle down a little bit? You can actually influence how the over-the-air resources are allocated as you know more about the application. You can actually design your forward error correction algorithms to fit the wireless interface. And of course, you can have a very good selection of video and audio compression algorithms, compression standards, on top of the profiles, the specific profiles that you would like to use for those flows. So that's it. We invite you to see demos of this technology. We have this demo working upstairs on room 210. Thank you.
We've got a couple minutes left. Are there any questions in the audience for our panelists? All righty, well, go ahead.
With respect to tracking, do you all see inside-out systems getting to the level of accuracy that you need compared to OptiTrack and SteamVR and things like that?
Oh, I guess I have a microphone on. I don't need to go over there. I think what we're seeing is, depending on the type of experience we're designing, it can make a difference which type of tracking we go with. The demo that we have upstairs, we are using inside-out tracking on that. So when we get the requirements in, it's like, how accurate do you need to be? How close, are we single-digit millimeter? Is a couple inches okay? So that could make a difference. The other thing is why can't we just blend multiple tracking? So maybe we have two types of tracking on the stage for different reasons. So yes, we're looking at all of those things. Specifically, you're asking, like, can inside-out get accurate enough? I think we've yet to see at what scale we can push it out to. I think the little demo we're doing upstairs is definitely, I think we could do something that size, but we want to go bigger and bigger and bigger. So what does it look like when we get to, 100 square feet, something like that, or 1,000 square feet on up?
Yeah, completely agree. It depends of how much it scales.
Yeah.
Any other questions?
All righty, fantastic. Let's give them one more round of applause.